Okay, let's continue. We're on to PARAM's geometry, and we're just going to take our one node. Oh, what is it? Something. It's field studies. So what I did was I did a script for this, which isn't too hard to figure out, and making some interesting geometry from field studies in a way that I don't think anyone else would, and that's what's the point of learning these nodes. So what is a field study? Let's jump into here, and I don't know if I baked something here. I have. Let's get rid of it, and let's go into wireframe, or let's go into shaded, and there's the form. And I can't honestly say I would ever make that in Rhino. Now, whether or not you want to make it for ceramic sense, or furniture, or fluidity, or porcelain, or whatever you want. Let's see how it's made. I made a circle. Pretty simple. I took a surface of that and I populated it. And it populated inside of it, but it also populates less if I want. So I can also, what's nice is the populating 3D will go to a kind of a big boundary, a square boundary. But this one actually populates within the core, which is nice. So I just kept it 13 count. And then in that, I just thought I'd grab a couple of three numbers. So there we go. I just grabbed 1, 2, 3. Why did I do that? Well, I took point, and point in the cloud, and have that internalized in here to a point closest point, and I say, okay, out of these 3 points, what ones are the closest ones to here? And you'll say, well, why did you even bother doing that? Well, I did that as an amplification factor on this geometry to basically find the field lines, and this is information that you're going to have to watch a few tutorials, go into Vector, and take a look at what you can do with all these field tools. And they come in a later version of Grasshopper for Rhino. But here they are, a spin force, and a spin force at different points, which I've put in. And those points I've actually installed as places around. So it's a case where I am dependent on a script, but since I internalized them, I'm not really. And a field can be built, and those are your fields. That's a reason to use a field param. That said, I've taken a field line from that and started to generate it through that amplification. So if I draw this out and change that, it's going to take a little bit of time to change it because the script is kind of slow, and you have to realize you can't do as many acrobatic feats that you thought you could do on other things. But in doing so, I grabbed it. I thought it would be nice to jitter up those items and basically move them. That's all I want to do is I move them in a jittered sense, but I don't want the number count to be too high. I think 3 is enough. So I'm jittering them in a way, and I could seed it differently to see what happens. Let's just throw a seed in here in case I feel like changing it later. We're going to move them in lines. We're going to dispatch them to a set of 2 polylines and 1 polyline, and we're going to bring them into a loft. Now that's going to take a second for it to decide what it wants to be. And what happens when I start to change the seed to this, you're going to see it's going to take a minute to commute. I've got a very strange system of building geometries that I probably, not too many people doing field studies would have generated these. But like again, what a tool, what a parametric tool to build some pretty cool surfaces that can then be offset to their normals later on through another script that I doubt very much in Rhino I would ever take the liberty to go on and try and render. So that said, that's a complex little script thinking about what's the use of a field line. So I just connected it here. There's the field line, and how I can use it. Well, I watched a tutorial that gave me the basic script, and then I modified it. And in the end, I think I've made a pretty cool script that's based on a very low count of these items. Actually, the count here on this parameter is 10, and that's one that I'll put up on GitHub. Have fun with it. I mean, that really is the essence of what I think I'm doing with these, trying to find a way, as I seed it differently, how I can build different geometries. And what I like about this is it does take a little while to commute, so I'm dealing with some pretty cool NURBS surfaces. And you can see the count is we're almost up to a second on each generation. You can see that within your display and going into your canvas widgets and looking at your profile. That'll tell you how slow your script are. So what a way to build these strange little toilet bowl shapes. But I'm having fun with it, and they're all field dependent. And that's how I start to wrap my head around conceptually what I'm doing. Purpose being, I think art is kind of a purposeless purpose, disinterested interest, and we'll see what ends up coming from it. Thanks very much for watching. We're going to go into pretty hard next script. Uh, geometry, geometry cache, and geometry pipeline, and then we should be able to finish with grouping and transformations. Then we'll move on from params onto the more difficult and interesting realm of primitives and what those actually entail and what you have to bring in, which is a little more complex than lines and points and vectors and certain maths. Thanks for watching.